All right, today we're going to continue our journey through Unit 4, Probability and Statistics. So this is Step 22 notes. I can interpret and fill in two-way frequency tables. So we're going to talk about tables, and then we're going to talk about the terms relative, joint, marginal, conditional. So two-way frequency tables. We've defined the word frequency before. Frequency just means the number of. So two-way frequency tables show the relationship between sets of categorical data. So we use tables when we have categories. We have to display the variables appropriately, depending on whether they are numerical data or categorical data. The rows show one of the categories and the columns show the other category. So it's each category, one category across the top, one category down the side, their intersections in the middle of the table. So a two-way table is a frequency table that displays data collected from one source that belong to two different categories. So there's one source collecting two different categories. The word joint means inside or what they have in common. Joint, they both have. So this is an inside number in the table. So it's each entry in the table. So it's the number belongs to both categories. So on this table here, the joint frequencies will be these numbers that belong to both categories along the top. We'd have category 1. On the side, we'd have category 2. The inside numbers that belong to both categories are the joint frequencies. Marginal means total. See the word marginal, I want you to think total. The total columns, which are the sum of the rows and columns. So the sum of the rows and columns are these 4, and then this last box, this is the total, the total amount that were in this data, this observation, this study. The total amount goes in this bottom right-hand cell. Conditional probability. This is finding the probability of an event given that another event has already occurred. So this will make more sense in practice than in formula, but the formula is the probability of B given that A already occurred is the probability of A and B occurring, so that's a joint frequency, number, because it has to belong to both categories, divided by the probability of A, and the probability of A is the given piece. So the given piece is, you're always going to be given one piece of data. You're going to know one thing. Say if these categories were boys and girls, we would know the total of one or the other. So you're dividing by the given amount, which is a total column. Okay, so let's complete this two-way frequency table. Okay, in general, if I have 2 out of 3 pieces here, then I can find the third. So I can figure out the total boys, because I know there were 12 that made their basket and 9 that missed. So now there's a total of 21 boys, and then just double checking the 21 plus 27 equal the total of 48. So there were 48 total boys and girls this day when they collected this data. I can figure out how many girls made their basket, because I know there were 26 total that made it, and there were 12 boys that made it, so that means there were 14 girls that made it. And now I can do either subtraction. But you know there were a total of 48, and 26 made their basket. Then I know 22 missed, and 27 total girls minus the 14 that made it means there were 13 that missed. So answering the question, how many girls made a basket? How many boys are in the class? How many baskets total were missed? Okay, the owner of a snow cone stand keeps track of the sizes and flavors one afternoon. So those are the 2 categories, the sizes, small and large, and the flavors, cherry, grape, watermelon, are the 2 categories. He sold 125 snow cones in all, so that's like our total. He sold 125 total. Of these, 40% were large snow cones. 40% of 125 is 50. So I know there were 50 large snow cones. %were grape. So again, we're just talking about of these. So of these 125. %, of 125 is 40. So I have 40 that are grape. And 12% were small watermelon. Okay, so those are the 3 percentages we know. We filled that information in. We know the stand sold 15 more cherry snow cones than grape. So 15 more cherry than grape. So however many grape was sold plus 15, and that equals the number of cherry. 15 more cherry snow cones than grape. So what can I do with that? Well, I know the total grape is 40. No, I'm sorry. The total of small grape and large grape is 40. So we'll use this information when we need to. We know the most popular snow cone of the day was small cherry with a total of 35 sales. So small cherry had 35 sales. Okay, that's all the information we've been given. So now we got to figure out how to fill in the missing pieces. So now we've got one extra row than column than the 2 by 2 above, but that's okay. Now we're looking for 2 out of 3. Columns and 3 out of 4 in the rows. Okay, so 125 minus 50 tells us that there were 75 small snow cones sold that day. If there were 75 total, 15 watermelon and 15 cherry sold, then there were only 25 small grape sold. If there were 25 small grape, then there were 15 large. And now I think we need this piece of information here. Grape plus 15 equals cherry. So if there are 40 grape plus 15 more tells us there's 55 cherry. And if there are 55 large, no, 55 total, 35 large, sorry, I said that wrong. 55 total, 35 small, then there are 20 large. And the last two subtractions, 50 total minus the 20 minus the 15 tells us there are 15 large watermelon. Now I just want to look at my table and make sure everything looks like it adds up. 35 plus 25 plus 15 is 75. 20 plus this 30 is 50. This would be all adding up to 125, and across that adds up. That adds up, and that adds up. So you can always check your table because they'll all rows and columns will total out correctly. So how many large grape snow cones were sold? Large grape. Large grape, there were 15 How many watermelon snow cones were sold in all? How many more small snow cones were sold than large? So the total small is 75 and the total large is 50. So it's asking how many more small snow cones were sold than large. There's 25 more. Okay, now we need to talk about the terms. Again, same terms, now we're adding the word relative in. So, a joint relative frequency, word relative means percent. So now we're talking about all these numbers, but now in percents. So the joint relative frequency are the values in each category divided by the total number of values. So we take the joint numbers, which are the inside numbers, divide by the total. Divide by the total, multiply by 100 to get a percent. The marginal relative frequencies are the total columns divided by the total. Total columns and rows divided by the total. So the sum of the joint relative frequencies in each row or column. And the conditional relative frequency is the ratio of a joint relative frequency to the marginal frequency. So it's a joint number divided by a total number, which we find by using a row total or a column total of a two-way table. So, Christy surveyed several students at her school and asked each person what foreign language he or she is studying. The result is shown in the table. Make a relative frequency table. So, this is the frequency table with just the numbers. The relative frequency table is going to take that same information, those same numbers, and just turn them into percents. Word relative means percent. We find each percent by dividing by the total. Well, the total is 80. We're going to take each number, divide by 80, multiply 100, multiply by 100 to get the percent. So there were 18 males taking Spanish. 18 out of 80 is 22.5%. And the relative frequency table should always add up the total totals to 100%, like 100% of the data. So all these values are out of 80. I know that 50 plus 50 is 100. I'm going to check the 47.5, 35, and 17.5. And they do all add up to 100. So I know my relative frequency table is complete. So all of these numbers out of 80 times 100 turns them into a percent. So the relative frequency table is the same data as percents. So now it says find the joint relative frequency, so it's going to be an inside number. Of a female student who's studying French. Females studying French is 15%. And now, given that the student is a boy, so we know they are a boy. How many total boys are there? $40 or 50%. What percent took French? So out of those 40, 16 took French. So I'm going to write out the formula and then we're going to lead back to 16 over 40. So the probability of A, given that B already occurred, is the probability of A and B divided by the given piece. So in this case, the probability of B. So the probability that they took French, given that they're a boy, that it's definitely a male. Well, the total males, if we're dividing by the total number of boys, so that's the piece we're given, and in the numerator we need what the two have in common. They took French, preferred French, and were a boy. So the total boys are 40, and then out of those 40, 16 prefer French, study French. So 16 out of 40 times 100 be 40%. So we looked at two-way frequency tables. We defined the terms relative. Relative means percent. Joint means an inside number. Something both categories have in common. Marginal is a total. And conditional means based on one category, given a piece of information.